Hey, good morning, everyone. It's Meteorologist Thomas Patrick here on this Thursday edition of Weather Classroom. Hopefully, you're all doing very well today on this Thursday afternoon. So, back today with a topic that actually one of my friends helped me come up with. It's on temperature whiplash. And to kick things off, I remember I was doing some research on some possible topics, and the weather really wasn't all that exciting, and I wanted to hold off on eclipses for a little bit later this month. And my friend was like, hey, it snowed 2 days ago, and it's 70 degrees today. It's like, what's up with that? And I'm like, actually, that's a pretty good question. Temperature whiplash. We've been getting, especially in the wintertime, we can get some really big temperature swings even just from day to day. And yeah, it's not uncommon to hear about a day where it snows a couple inches and then it might be 60 or 70 degrees just a couple days later, or vice versa in some cases. So let's go over that. How do we get these huge temperature swings? Why is it more common in the wintertime? And how do the mountains play a factor in some of this temperature whiplash, if you will? But before I even get started, for the couple dozen people that are already here for Weather Classroom, let me ask you a question that I'll be answering at the end of this video. What is the world record for the biggest temperature change ever? How many degrees did that cover in how short of time? That is the question I will leave you with at the beginning of this weather classroom that I'll be answering at the very end. So get your guesses in the comments below. And of course, if you love these weather classrooms, if you love the educational content that I can provide to you, please make sure to hit the like button both on this video as well as on my page as well, and you'll get the live notifications every Thursday at 1 p.m. Pacific time. So jumping into Weather Classroom, first let's go over some of the basics. What gives us our temperature swings, even from a day-to-day basis? And it all goes back to the jet streams, the two jet streams to be specific here. There's two jet streams that flow across the globe, both in the northern hemisphere and the southern hemisphere. So two for the northern, two for the southern. The polar jet stream and the subtropical jet stream. Both of these jet streams influence how the weather just happens in the United States, and between the summer and the winter time, we actually get influence from one or the other, and sometimes in the spring, they can actually get together and create some very dynamic weather. In fact, a lot of severe weather outbreaks come from these two jet streams actually interacting with one another. But to put things simply, it actually just divides three general air masses. There's a cold polar air mass in the far northern latitudes. There'll be the more temperate mid-latitude, in between, warm-ish air mass, kind of in between them, and then a more tropical, warmer, even warmer, and humid air mass here. And I tried to color coordinate it so that way your eyes can probably pick out that the temperature difference between these two air masses surrounding the polar jet stream are actually going to be a lot more than the two air masses that surround the subtropical jet stream. And that is how it works. Actually, it's the temperature differences that creates the circulation that drives the jet stream forward. Think of like gears. Like the temperature changes one gear, that changes another gear, that creates the jet streams to flow in the first place. It's a whole dynamic meteorological process. But this is a bigger influence in the wintertime for the polar jet stream. Because in the wintertime, of course, the Earth is tilted away from the sun, so those jet streams and those temperature changes start to sag southward a bit, which makes the polar jet stream more at play over the US in the wintertime. So that's where we get our big temperature swings, is that when the jet stream, this wave, just undulates back and forth, and these temperature swings can be massive. In some cases, it can be as much as 50 degrees in just one day, and that is not uncommon, especially for the high plains of the US. So that's why the winter time can have bigger temperature changes. 30 degrees to 70 degrees in a day or two, not all that uncommon, especially if the jet stream gets this bigger amplitude feature to it. But in general, just wanted to show it to you like that. But that's across the entire US. The western US also has mountains at play, and the mountains are a pretty big deal when it comes to just how the temperature interacts and the wind interacts with those mountains. And there's a term you may have heard of called the Chinook winds. Those can actually be called the snow eater wind. So it's very common in the mountainous areas. Denver talks about the Chinook winds quite frequently because they're on the downslope side of the mountains, and it can very often snow. You get a westerly wind that falls down the mountain, and it just chews up that snow because it's so much warmer. What's happening there? What's the process? Well, the air that actually sinks down the mountainside, well, as it sinks down, well, the pressure gets higher, and that pressure causes the air to physically warm up by 10 degrees Celsius per 1 kilometer. That's actually what's called the dry adiabatic lapse rate, if you wanted to write down that meteorological term. That's actually a very intense temperature warming of an air parcel that falls down the mountainside. So thus, if you have just an even spread of temperatures from the the foothills or the valley floors all the way up to the mountainside, if the wind travels down the mountain, well, that air warms as it does. And yeah, temperature changes can be quite dramatic in this situation. And that actually kind of leads me into the rest of this presentation, including, again, that world record temperature change. Haven't seen any guesses yet, but again, if you want to guess what the world record temperature change is, make sure to leave those in the comments. So let's put this in Washington perspective. I look at some of our northern mountains and valleys here. In fact, this is actually a graphic that I used for our temperature inversion. So you can see that sometimes at night, the cold air sinks down to the valley floor because it's a colder, denser air, and then it can be warmer near the mountain tops. Well, in the daytime, if the wind is in such a way that the wind pushes the air down the mountainside, well, a couple things happen in this case. One, that air itself, again, warms as it sinks down to the valley floor. But then the second factor that happens is it actually pushes out the colder air, and that can make for some very dramatic temperature swings from the morning hours where it could easily be sub-freezing in the wintertime. And if you get this warm downsloping air, temperatures can easily pop into the 40s, 50s, and in some cases 60s and 70s if the situation is right. And I use that as an example because this leads me to the final point of my presentation, which is that world record temperature change. All those factors I just mentioned actually go into what happened in the world record temperature change. There was a big dramatic change in the jet stream from that colder air mass to the warmer air mass. There was the downsloping Chinook winds that warmed as they fell down the mountain, and it replaced a colder air mass via an inversion in the morning hours, so the temperature swing was dramatic. Any last guesses, anyone? What the world record temperature change might be? Well, here it is. It actually occurred in the US in Spearfish, South Dakota. That's on the western side of South Dakota near the Black Hills. So the Black Hills are actually a form of mountains. And I had a great opportunity to actually study this because Rapid City was my first TV job ever. And I got to see that very picture that you see here, that very, it's like a temperature graph. It's like a spiral graph. I actually got to see that at the National Weather Service office there in Rapid City. It occurred on January 22nd, 1943. And the temperature change that occurred at about 7:30 in the morning went from -4 Fahrenheit to 45 Fahrenheit in just 2 minutes. 49 degrees warmer in just 2 minutes. That is incredible and has been verified as the fastest naturally occurring temperature change worldwide. And it's all those factors that went into it: the jet streams, the two air masses, the Chinook winds, and the temperature inversion replacement. And it actually, if you look at this picture closely, and I'll try to point it out here, so what you're looking at here, and I believe if I look closely, midnight is I think it's right here. I think this is midnight, and each one of these lines is an hour. And the temperature is recorded here. And the closer it is to the center, the colder it is. And the farther away, the warmer it is. And what happened right here, you see it just jumps straight up. That's the temperature change. From 7:30 a.m. to 7:32, an increase of 49 degrees. But it doesn't stop there. It didn't stay 49 throughout the rest of the day. In fact, as the winds changed, look at this. Looks like it's 7, 8, 9, about 9 a.m., the temperature went back from the 40s back down to sub-zero again. And the temperature actually, those air masses sloshed back and forth throughout the day. It's just a really fascinating meteorological case study. In fact, I'll show you the page. As I was doing research for this, the National Weather Service has a page on this. It shows the air masses, so you can see, if you can see it on my screen here. I don't have a cursor. But the colder air masses in the northern plains, the northern plains, North Dakota, South Dakota, but there is the warmer air mass to the south. It has the frontal systems here at 6:30 near noon, and then later in the evening, how those air masses actually moved back and forth. But you also get, again, these like spiral graphs of the temperature changing very violently up and down. Really, really cool stuff. But yeah, that is the world record temperature change, 49 degrees in just 2 minutes, because it goes back to all those factors that creates this temperature whiplash, which is more common in the wintertime than it is in the summertime. It's the polar jet stream that creates a larger temperature difference. It's actually the other way around. It's the temperature difference that creates the stronger polar jet stream, if we wanted to give you full points on a meteorological test here. So bigger temperature changes are more likely in the wintertime, because the summertime, it's the subtropical jet stream, which, yes, can influence temperatures, but usually by only about 10 or 20 degrees instead of 30 to 50 degrees. And those downsloping winds off the mountainsides down to the valley floors, those are known as Chinook winds, or colloquially as the snow eater, because those are very warm winds that slope down the mountainside and can warm things up significantly. And oftentimes, if you have a Chinook wind, any snow that's on the ground probably is going to be gone very soon. And actually, that's very common in the Denver area. So there you have it. Big temperature swings. We're getting into the winter season, so I know we're going to see that. And of course, here in Spokane, Washington, we're getting a little bit of that for this week as well. It was 60 degrees yesterday, the first 60-degree day since 2016 in Spokane, and I have 30s in the forecast all of next week. Not the most dramatic swing in temperatures, but obviously we're going to see that in more commonality in the next few months than we would otherwise. So yeah, there you have it. Hopefully you learned a little bit about how we get these big temperature swings, how it can go from 30 to 70 degrees in just a single day. And those are just high temperatures. That has nothing to do with even from how cold it can be at night to how warm during the day. That's a whole different subject on moisture and what's the word I'm looking for there? Diurnal heating and stuff like that. So yeah, this is just on temperature swings. Again, if you love this educational content, I certainly love presenting it. Please make sure to either hit the heart button or the like button on this video, and please make sure to like my Facebook page at Meteorologist Thomas Patrick, so you can get the live notifications every Thursday at 1 p.m. Pacific time, or should I say most Thursdays. Sometimes I have to either take vacation or fill in for others, which might limit my time otherwise. But I am planning to do one every Thursday this week, so it should be exciting. And if you have any weather topics that you would like me to cover here on Weather Classroom, please make sure to hit me up. Just send me a direct message or just leave me a message in the comments below as well. Would love to hear your thoughts. Again, this was a topic that was suggested by one of my own friends, so I'm always listening and always taking those suggestions. But that'll do it for today. Have a great Thursday. Have a great weekend, everyone. And yeah, stay safe, stay happy, stay healthy, and we'll see you next Thursday here. Thanks again, everybody, and I'll see you later tonight on the news as well. See ya, everybody.